On behalf of AFAA New England, I'd like to thank you for joining us today. We have a great session in store, and I'm looking forward to it. Before we get started, I'd like to thank our sponsors for making AFAA New England programming possible. We have our platinum sponsors, Fire Command Systems, J&M Brown Company, Mammoth Fire Alarms, Norell Service Company, the Siemens Smart Infrastructure Division, and Space Age Electronics, as well as our silver sponsor, TC Life Safety. Today's session will be recorded and posted on our website for those of your colleagues who aren't able to make it today. If you have questions during the session, please use the chat feature, and if we have time, we'll get to them at the end of the session. So I'd like to introduce today's speakers. We have Carson Cook, a senior fire protection engineer with Jensen Hughes, working out of the Framingham and Boston offices. Carson has 10 plus years experience and has been with Jensen Hughes for just over a year. Prior to Jensen Hughes, Carson worked for an MEP firm in Boston. Dave LeBlanc is vice president with Jensen Hughes, working out of the Framingham office. He has 28 plus years experience and has been with Jensen Hughes his entire career. Dave is a technical committee member on NFPA 3, Standard for Commissioning of Fire Protection and Life Safety Systems, NFPA 4, Standard for Integrated Fire Protection and Life Safety System Testing, as well as NFPA 72, the National Fire Alarm and Signaling Code. He's also the vice chairman of the Massachusetts Board of Building Regulation and Standards for Fire Protection, Fire Prevention Committee. So thank you very much to Dave and Carson for joining us today. And guys, why don't you get rolling?
All right, thank you for that introduction, Jerry. Can everybody see, everybody can see my screen with the cover slide now, Jerry?
Yes, it is advancing.
Yep. Okay. So appreciate everybody joining today. Dave and I have pulled together this presentation on smoke control system IT&M. We hope you enjoy it. A little bit about us, Jensen Hughes, for those that don't know. International company focused on, fire and risk. So basically anything under the sun, fire and building safety, risk and hazards, emergency management, security, and forensics. These are just some of our key service offerings, but we'll dive right into it. So the agenda for today, we're going to go over the applicable codes and standards that apply to smoke control design, installation, and testing. We'll get into the overview of smoke control systems, touch upon special inspections, talk about routine testing once the system's installed and commissioned, and then like Jerry said at the end, if we have time, we'll do Q&A, but feel free to use the chat function, and Dave and I will try to respond as we go through. So the applicable codes and standards, we understand that this is the New England chapter, so these are the codes that are applicable in the New England states right now. Most of them adopt and amend the 2015 IBC. Portions of the IFC are adopted and amended in Connecticut. NFPA 1 is adopted by all states, and then NFPA 92 is adopted through the Fire Code, the 2012 edition. So when are smoke control systems typically required? When do you typically see them? This is a list of the most common applications, but there's also others out there. Stair pressurization you'll find in high-rise buildings and underground buildings. So that's buildings, in Massachusetts that are over 70 feet tall, or outside of Massachusetts, 75 feet or more, the highest story above the lowest level of fire department access. And then underground buildings would be, buildings 30 feet or more above the highest level of fire department access. Elevator pressurization, you typically see that in high-rise buildings as an alternative to enclosed elevator lobbies, but you also could see it in residential low-rise occupancies. And then there's the active smoke control systems. Those are the ones that people typically think when they hear smoke control, and that's 3-story or taller atriums, smoke-protected assembly seating, stages over 1,000 square feet or taller than 50 feet, underground buildings, and then older high-rise buildings, especially in Massachusetts. Additional systems could exist as a result of older code requirements, such as vestibule ventilation, stairwell exhaust, and sandwich systems. But these are typically you see the newer, in the new construction is where you'll find the majority of these. So I think before we dive into this, there was a request to talk about smoke dampers. Smoke dampers are not part, or sometimes they are part of the smoke control system, but they when they're not provided as part of a smoke control system, some common applications are shaft penetrations and smoke barriers. So you'll have fire smoke dampers at shaft penetrations. And then smoke barriers, elevator lobbies, healthcare. The method of actuation is typically through duct-mounted detectors or area coverage. You could have sampling tube type or in duct type, or you could have 100% area coverage provided throughout the space served by the associated penetration. The method of control, how these are typically actuated, they can either be hardwired to an integral conventional detector that's wired and factory mounted by the damper manufacturer, or you could have control wiring from a relay module, standalone relay, or an integral relay of addressable detector. A common question we always get is, when is end switch supervision required? If it's not part of a smoke control system, it's not required. It's typically then provided at the owner or engineer's discretion. So diving into smoke control systems, they're not just a single system. It's not just the fans and the dampers and the ductwork, which is the HVAC portion, but it's an integration of a number of building systems. So you have obviously the HVAC component, but then there's the automatic sprinkler portion, which is used to activate a system. You have the fire alarm and detection, which is either at minimum initiating it, but most of the time, and we'll get into it, is controlling the system. You could have the building management system doing the control and supervision of the equipment. You'll see that in a lot of the older systems. It's not that common, at least locally in the newer ones. You could have doors and dampers that are providing makeup air, especially in atriums. And then you have obviously the normal and standby power system that is powering everything. So as you can see, it's not just a single system, it's an integration of a number of building systems. So the design basis for newer systems, at least, the engineering has progressed over the years. Atriums, smoke exhaust, smoke control systems, they're typically engineered these days through CFD models, which could include egress modeling. Stair and elevator pressurization, those systems are designed to maintain positive pressure differential in the stair or hoistway relative to the building. They have variance performance requirements. So stair pressurization systems are designed with all of the doors closed. Elevator pressurizations are designed with all of the doors closed except for the floor of recall. An atrium smoke exhaust is designed to, under current code, maintain the height of the smoke layer interface at least 6 feet above the highest walking egress system within the smoke zone, in addition to a tenable egress environment. And a tenable environment would be temperature, visibility, and carbon monoxide. Older atrium systems, you'll see that they were designed for an air change per hour based upon the atrium size or height. Some common mechanical system arrangement for newer smoke control systems. Typically, these are dedicated. They are at least required to be for stair and elevator pressurization. You'll typically see a dedicated supply fan, usually on the roof, if it's unless it's a super tall high rise, with injection points into the stair and hoistway. With smoke exhaust and atriums, you typically have dedicated exhaust fans that are also on the roof with ejection points at the top of the atrium. And then for makeup air, you'll see that via natural openings, so that could be operable doors or windows, or mechanical means with supply air fans. So some common newer system features that you'll see in a smoke control system, you'll have a UL 864 UUKL listed control system. Like I said, it's typically the building fire alarm system, but sometimes it can be the BMS for complex systems where you may be having non-dedicated equipment doing dual duty. As part of that system, you're going to have initiating devices, so pull station, smoke detection, sprinkler, water flow switches, what's automatically initiating that system to operate. As I mentioned previously, you'll have operable doors and windows that are providing makeup air. So those are automatically opening in a smoke event or a fire event to provide makeup air to the required exhaust system. The big one that comes obviously is forefront in people's minds is the smoke control panel, the graphic firefighters panel that provides status and override of the equipment for the building. So you'll see on the right here, we have a figure where it has an elevation of the building. It shows stairs, hoistways, airflow paths, injection points. It has HOA switches, that's handoff auto switches with LEDs, indicating on, normal, off, and fault status for each equipment. And then you'll have trouble horn on the panel. You'll have a lamp test, which you can press and illuminates all the LEDs on the panel. You'll have the overriding gauge, which is usually key to the local fire department. And then you'll have a legend on the panel that indicates what all the equipment and LEDs are for. You'll have, obviously, we talked about the normal and standby power. So you have an emergency generator and automatic transfer switches to back up everything. System monitoring, so circuit integrity, monitoring power, damper and door position, and also fan status. And then you'll have 2-hour rated control and power circuits. So that could either be CIC cable or MI cable, or it's the actual physical circuits installed in 2-hour construction or outside the building. And that's when you have a stair and elevator pressurization systems. Also, you'll have obviously VFDs, which are typically provided in newer systems and that allow for balancing and providing a safety factor in the fan as well. So smoke control design documentation, what to expect for what's produced by the engineer of record. You'll have the fire protection narrative, which is required in Massachusetts and Rhode Island. And it's a high-level overview of the codes, the design methodology, what's involved in that. It's not just smoke control, but it's all the fire protection systems in the building. Obviously, the HVAC and fire alarm drawings are crucial to have a ductwork layout, equipment layout, the detection. There's the sequence of operation, which either could be on the fire alarm drawings or the HVAC, depending on what's controlling that system. There's a graphic layout of the smoke control panel, so you want the engineer to provide that and dictate how the panel is supposed to look. That then is utilized by a vendor such as Space Age, who produce a shop drawings for that. And then it's important that gets reviewed, not only by the engineer of record, but also the fire department prior to fabrication. So there's no issues when it gets installed out in the field and it's getting tested for final. And then the big item is the smoke control rational analysis. So that's the narrative that focuses on the smoke control system. It gets into the smoke control method, talks about stack effect, temperature effects, wind effects, the effects of normal HVAC operation on the smoke control system, effects of climate on the equipment. So, if you have a detector outside for the HVAC, say a stair pressurization fan, is it listed for the ambient conditions? And it talks about the duration of operation of the system and then the smoke control interaction with the building. So right now I'm going to turn it over to Dave, who's going to get into some third-party reviews, talk about special inspections, and is also going to get into routine testing, once the system's commissioned, what's required during the life of the building.
All right. So as you can kind of see, the picture on the right is actually a stair press fan in there, similar to a fire alarm system having redundant reliability with Class A or Class X circuits. Smoke control systems also have redundancy in things that need to be built into them. This example is of a mechanical system that has a 3-belt pulley system. So there's actually 3 belts in there. And, the code requirement is to have a 50% redundancy of the belts. So this belt, for example, this system, 2 belts is what the normal load would be. They have to add a 3rd belt just in case one of those belts breaks. So there's a lot of nuances and pieces and parts of the overall smoke control system. Like Carson had mentioned, it's a, kind of a integration of all kinds of different systems. Now, with that, Massachusetts also has a requirement that's unique to themselves in any of these new buildings with performance-based smoke control systems like atriums. You actually need a third-party reviewer, and that third-party reviewer looks at the design fire analysis, looks at the rational analysis, the timed egress analysis, any computer modeling that needs to happen. These systems are a lot more sophisticated, and it's very difficult, for local jurisdictions to kind of give it proper reviews. Even Boston, who have 3 fire protection engineers on staff, kind of uses the third-party review because it's a code requirement in Massachusetts. But it does allow for a little more thorough review of those smoke control designs, assumptions, and performance criterias. All right, so for all new smoke control systems, there's a smoke control special inspector that's required. And I'm sure if anyone on the call has been involved with smoke control, there's usually a lot more headaches than anything else with smoke control. There's a lot of misunderstanding about smoke control. And one of the challenges is because it is an integration of all these various systems, people normally only have, their piece of the pie related to smoke control that they have an understanding, and it's hard to kind of understand all the other moving parts and pieces and coordination items that need to occur. So hopefully you get a little insight with some of that stuff during this presentation. As you can see, the door on the right, kind of if you're on the other side of the door, that might be kind of getting involved with a smoke control system. You don't know what's on the other side of the door, and you get involved in kind of the picture on the left is where that door leads to. It's a 30-foot drop. So, smoke control systems, you can kind of get tied up in kind of sucked in pretty readily because there's a lot of misunderstandings with the smoke control systems. But the smoke control special inspector can be your friend. So that person's looking to kind of tie all those kind of loose ends and how that all kind of fits in together. So now, once again, for any new smoke control system or major modifications to smoke control systems, sometimes that includes fire alarm system replacements, whether you're kind of upgrading the panels or doing a full replacement of the fire alarm system. If that fire alarm system is also controlling smoke control, there are things you need to kind of watch out for that. But we're going to talk more like it's a brand new building, brand new job. So the IBC, basically everywhere in the country, requires commissioning of all smoke control systems by a smoke control special inspector. And there's qualifications that go along with that. So the smoke control special inspectors are required to have expertise with testing of smoke control systems. And as we talked about, the smoke control systems really an integration of a bunch of systems, including the fire alarm system. So an important thing to note. So I saw that we did have some AHJs kind of in the participants in the video chat today. So local building and fire departments have the authority to approve the smoke control special inspectors, and they should request qualifications of those firms not previously approved to verify their expertise. But it's satisfactory, and actually AHJs can reject smoke control special inspectors. So they have not only the power to approve, but they could actually reject smoke control special inspectors. But that smoke control special inspector is really supposed to kind of be able to kind of assist with the big picture view and the holistic integration of those systems into one cohesive smoke control system that performs like it should per design. So who should be a smoke control special inspector? Obviously, you need someone that has experience dealing with smoke control systems. Sometimes you see that they're part of the design team if it's new construction, and they're familiar with the project. Might be a good choice. A project code consultant or fire protection engineer that has experience with smoke control systems. The firm doing the performance analysis, if there's like atrium modeling, that sort of thing, if they have experience with actually testing smoke control systems, they might also be a good choice. Kind of what you want to do is avoid, though, the engineer record. So if a MEP, a mechanical engineer, is doing the smoke control system engineer record, They have engineer record responsibilities for the job that they're supposed to be taking care of. This smoke control special inspector is another person to kind of oversee that stuff. And at the end of the day, kind of not all smoke control special inspectors are created equal. Once you need that, but two, there's two main different types of smoke control special inspectors. The ones that kind of, cite the issues, but hopefully you kind of have one that's kind of more helpful than that. So someone can kind of just gives code citations, like pulling a hand grenade, tossing it in the room and walking away and just saying, hey, it's your problem to fix. Or you have one that's more helpful and kind of a team player, and they're looking to kind of share their expertise and experiences to kind of give you or give the team, better insight on how, not only that there's a problem, but what are some of the possible remedies? What they seen that works before? Kind of those types of things. So they might be bringing some bad news that something's not working, but they can also offer solutions that the design team could adopt and utilize to kind of make bring that to a successful conclusion. So as part of the smoke control special inspector for this new construction job, they've been involved, through the duration of the project. So during construction, they've been in the field doing rough inspections. They developed a smoke test plan to tell everyone how they're going to, test this smoke control system. They've reviewed submittals and cut sheets to make sure kind of all the pieces and parts. So that includes the fire alarm pieces that are interacting and interfacing with the smoke control system. That includes some smoke control requirements for the fans. It includes, sprinkler system reviews. It includes a lot of different kind of things to kind of coordinate the integration of those various systems, which eventually lead up to testing, right? So, like as you're all aware, fire and life safety systems are some of the last systems to get, tested and accepted when opening a new building. Smoke control is on that list of one of the last ones that kind of gets done, because a lot of times you're even having your fire alarm signed off before the smoke control system is fully signed off. So there's a lot of work that kind of goes up front, and hopefully, kind of you have a smoke control special inspector plugged in way before to try to help avoid the things, because it's a lot easier to change things on paper than after they've been installed in the field. So, having a good experienced smoke control special inspector is vital. And then you got to do all that testing that you need to do to make sure that holistic approach and everything's the input and outputs are working properly. The intended sequences are working properly for the smoke control. The performance measurements are working properly for the smoke control system, with whether it's CFM or pressure differentials or, all the various metrics that need to be done on the mechanical side of things for the performance, are vitally important to kind of make that all occur. But documentation is also a big part of this. So kind of, they're involved in doing all this stuff, but there's a requirement to have a smoke control special inspecting report. And that kind of like combines all the things during the design construction phases leading up through the testing and kind of puts it in one location. And that smoke control special inspection report includes duct leakage tests that kind of they have to see how leaky those duct works are kind of way at the beginning of the project. There's a smoke control test plan that gets developed that tells everyone involved, including, the fire alarm contractor, kind of what have you, of, what are we going to be testing? How are we going to test it? Coordination of all those various subcontractors and disciplines to make sure we have our I's dotted and T's crossed and we don't have some things missed, such as, kind of no one's monitoring the damper status for smoke control positions, or, how we proving the stair pressurization is proving on. There's a whole lot of different things that kind of go into that. And that should be all brought out early in the test plan. But that test plan gets included in that finalized report at the end of the job. the commissioning form, such as the daily form showing all the identified deficiencies in their correction. So there could be a whole lot of deficiencies identified and they've been corrected, but it kind of shows the evolution of the system coming together. The certified air balance reports with the performance measurements of the smoke control system. So that's from your certified air balance contractor, and they're measuring stair pressurizations, they're measuring atriums. There's all kinds of different things that we need to measure, fan performance. There's a lot of different things that kind of go into it. And then there's also a requirement to have an integrated set of control diagrams showing all the smoke control equipment in their controls. Now, the code tells you need to provide it. They don't tell you how best to go about it. So whether the fire alarm system is controlling the smoke control system, or it's just an input into a BMS system that's going to turn the smoke control system on. Generally, what I recommend is if you take a good set of your fire alarm drawings, shop drawings, or as-built, and use that as the starting point for your control diagrams, it's going to show you all of the devices that is initiating the smoke control system, whether that's the smoke detectors, sprinkler water flow switches, in some cases, manual pull stations, and all of those things are shown on the drawing. And then the other pieces of equipment, the fire alarm has a lot more pieces to it with field devices all over the place. It's easier to add where the air handling units are to that drawing, where the variable frequency drives. There's the photos right next that you see to the right there is a variable frequency drive, also known as a VFD, and that lets the certified air balancer tweak the fans on the smoke control systems, and by changing the frequency, it changes the amount of voltage that's going to the fan and actually how fast that fan spins and how much CFM it puts out. So it gives them another layer of control. Those are things that the VFD gets monitored by the smoke control system, which, like I said, most of the time is the fire alarm system. So there's different things that we want to kind of monitor, such as, kind of power, kind of turning that unit off, disconnects. There's all kinds of different things that we want to pick up on the fire alarm side, particularly if the fire alarm's controlling the smoke control system. But that integrated set of diagrams, we show where all the major pieces of equipment are. So the VFDs get shown on there, the air handling units get shown on there, kind of where the current, where the circuit boards are that's feeding the power to the dampers and fans and to the VFDs, to kind of make sure all those things, where those things are located. And really why those things are so important, we'll see this in a little bit when we start talking about inspection, testing, and maintenance of existing systems. The more that's laid out in one combined set, so you don't have to kind of go through 10 different drawing sets. You don't have to run to a mechanical set and a fire alarm set and an electrical set and kind of to pull together the information. All that's kind of pulled into one combined control diagram set that kind of shows you everything involved in smoke control on one set of drawings. That smoke control test report needs to be reviewed by the engineer record, so that the mechanical from the MEP firm typically is the one doing that, and they're required to sign, seal, and date confirming the design intent has been achieved. And then kind of once you have that smoke control report from the smoke control special inspector, that's provided to the authority having jurisdiction, and that's normally when that test is scheduled, kind of to perform the smoke control test with the authority having jurisdiction. So what we've talked about so far is kind of an overview of the smoke control system. We've talked about a little bit more about new construction and new buildings and things that you're faced with, and a little bit about the smoke control special inspector, so you're kind of aware of that. But a lot of things that we really wanted to get to is, kind of the ongoing inspection, testing, and maintenance for existing smoke control systems. So a lot of that stuff we're hoping that will help you better understand kind of what we're going to need to be doing as part of ITM for existing smoke control systems. So first off, any owner, basically anywhere in the U.S., is required to maintain any fire and life safety system, whether it's a fire alarm system, a sprinkler system, or smoke control system. So smoke control systems are required per code to have routine inspection, testing, and maintenance. There's a requirement to test those dedicated systems semi-annually. So dedicated systems are typically your stair pressurization systems. Annual testing is required for non-dedicated systems. So as an example, if you have below grade spaces that go beyond 60 feet and you have a smoke control system as part of that, normally that's done with normal HVAC equipment that's also doing the normal supply and returns for that. In those, since they're used more often, if they tend to break, someone's going to complain because it's too hot or too cold in the building. So that's the difference why a smoke control test for non-dedicated systems, because they're basically exercised on a daily basis or a weekly basis, and they get kind of fixed much more readily, as opposed to the stair pressurization system that's just sitting there. It's never really being utilized except during the emergency condition or during testing of the inspection, testing, and maintenance. The other piece of why semi-annual testing is required is, as you all know, there's requirements for testing of all fire and life safety systems, but unfortunately, by far, the smoke control systems for those existing systems are the most neglected and the least likely to have regular inspections, testing, and maintenance done on them. So there is a reason why some of the codes also kind of not only enforce that, but the codes did adopt a weekly self-test requirement for new smoke control systems because of the lack of maintenance and inspection and testing that happens on smoke control. Now, some of it is because there's a challenge. This smoke control system it's not just one system. It's a combination and integration of a bunch of systems. So unlike if someone wants to service their fire alarm system, there's a lot of fire alarm system service companies out there. If someone wants to service their sprinkler systems, there's sprinkler service companies out there. But there's no such thing as a smoke control service company, because really, to do that properly, it's really a bunch of service companies that need to get pulled together to kind of properly maintain that system. Fire alarm being one of the integral pieces to that. So when we're testing these smoke control systems, the testing is intended to confirm the system performance and the operation as required at the time of the installation. It's not trying to meet new code requirements for that smoke control system. It's trying to confirm that it meets the stuff at the time it was originally installed. That doesn't mean that the testing criteria can't change. So the testing, just like with NFPA 72, you might have a 20-year-old fire alarm system, but your testing needs to be in accordance with the most recently adopted NFPA 72 version for testing in your local jurisdiction. So same thing applies for smoke control. But there's some other nuances. So we're not only testing some inputs and outputs, but we need to also test this stuff on normal and standby power. So we're talking about emergency generator power tests, which kind of drive owners crazy. They don't like testing their occupied buildings on emergency generator. But that is required even for the semi-annual test. So every 6 months that's supposed to be occurring. That testing is required to determine airflow quantities and pressure differentials. So that certified air balance person needs to come through and take all those various measurements. The HJ also, like other life safety systems, need to be notified when any smoke control system is out of service for more than 4 hours in a 24-hour period. And again, upon system restoration. So there's some notices and things that are go along with a lot of the other fire and life safety systems. You got to document that the test results required to be maintained and kind of made available for inspection. So those, that semi-annual or annual test report for the smoke control system needs to be provided to the property manager or to the owner so they can kind of hold on to it. But one of the things that we also see is that sometimes there's confusion. So some jurisdictions really, really enforce the inspection, testing, and maintenance of fire and life safety systems, and others do not. Now, you've probably seen some of that on the fire alarm side. It gets even worse on the smoke control side. But at the end of the day, the way the codes work, these things are required. They're not only required when the local HJ is enforcing them. So if a local HJ is not enforcing these requirements, first, they should be. But second, even if they're not enforcing those requirements, that there's a requirement by the owner to kind of have this work done, irregardless of whether it's being enforced locally or not. So, here are a couple pictures of a old stair pressurization fan on a rooftop. It's like a mushroom type kind of fan, and a stairwell pressurization disconnect switch. Kind of on the bottom picture there. So what are some of these annual and semi-annual testing procedures? Well, you got to involve the whole lot of people. So we're talking about, you need the fire alarm contractors involved, the sprinkler contractors involved, kind of HVAC people involved, air balancer, and kind of a electrical, or someone from the building that's comfortable with dumping building power, in a lead testing agency. So that lead testing agency, really is acting like the smoke control special inspector for this, semi-annual test. So you really kind of want an experienced fire protection engineer that knows the ins and outs of smoke control and kind of can tie the bits and pieces together to, kind of thread all of those integrated systems together to work as one. Now, during that testing, we're not only verifying the automatic sequences, we're verifying the manual sequences, since the newer systems, kind of have, smoke control panels, firefighter smoke control panels, whatever you want to call it. Here's an unsolicited plug. So Space Age Electronics makes a great custom graphic smoke control panel. We're kind of lucky to have them locally here in kind of New England. It does provide a lot easier access to those custom panels, and they actually even particularly, we've ran into this a few times with existing smoke control. We've had to provide a smoke control system graphic. It's customized. Everyone had signed off on it, and then lo and behold, once we're in the field really digging into things, something pops up that no one knew that the system was configured this way, or kind of what have you. And Space Age actually makes some very nice, professionally looking patches that can kind of go on the existing, smoke control panel, and it looks really sharp and blends right in. It's very hard to kind of see what it is unless you're looking for it. But those manual sequences are very important to kind of make sure, because we check the priority. They're supposed to have a number one priority over everything else. We verify system priorities. You don't want, the HVAC system, freeze stats that kind of turn off the fans if it's too cold outside, turning off in the middle of a smoke control system. The smoke control systems kind of run till they're sacrificial. They kind of run. There's not really safety interlocks that stop them from running per se like that. So we need to kind of verify those priorities are in place, and that there's not things that are going to stop the smoke control system from running when we really want them to be running. We also need to verify faults. So that's, so we test every single light on that panel. So, the green on light, on is on, off is off, open is open, closed is closed. And we need to kind of get positive confirmation in the field that we're reporting back the right information. So that includes taking belts off of fans to make sure we're, the fans are running, but they're not pushing any air movement. We want to make sure we're not showing that fan is on and running. So there's a lot of things that kind of go into that, kind of for that, and that lead testing agency can, kind of coordinate all those service companies to kind of come in and do those tests that are needed. So we also need to measure system performance on normal and standby power. So there's a lot of different things that kind of go into it. The bottom right picture, right? You kind of see this is an outside emergency generator at one of the buildings that needs to automatically turn on. So a lot of these testings, we do a number of the tests, but the kind of the large big event, the big test that we normally do is we take out all the bypasses on the fire alarm system. The whole building's kind of in its normal state outside of having the master box or the central station kind of offline, because you obviously don't want the fire department rolling. But one of the final tests we actually do is we actually create a sprinkler water flow from an inspector's test connection up in the building. And that's going to start, a water flow for the floor. It's going to turn the fire alarm system on. And if it's a high-rise building, you're going to get, the 3 floors, that will, after the pre-alert, kind of go into alarm. The fire pump kicks on, and we do this all under normal power. So the speakers are going off, the strobes are going off, the fire pump's running, the stair pressurization fans are running, kind of like there's a lot of stuff in the building running, and we're all on normal power. And then we kill building power. So one of the pictures that you kind of see in the upper left-hand side is the fire pump disconnect switch. So that fire pump disconnect switch, a lot of times the fire pump is wired ahead of the main disconnect for the building. So to drop building power, truly, you got to actually drop 2 things. You got to drop the fire pump main disconnect and the main building disconnect. And so that's why we kind of need the electricians involved and that sort of thing, so we could drop, power to the entire building. So our overall system, fire alarm, sprinkler, fire pump, smoke control, everything's running on normal power. And then we dump the fire pump and the emergency power, the standby power to the building completely to verify that the emergency generator turns on, the automatic transfer switches switch over to re-engage all those various systems, the fire alarm, the fire pump, the smoke control system, that, all that stuff kind of is now getting fed from the emergency power. So, it's an involved test. The upper right-hand picture is a test where someone's taking, this is actually from an elevator, and they're taking measurements from the elevator to the floor for an elevator shaft pressurization system. So there's a lot of moving parts and pieces to kind of coordinate, kind of with these systems. And then finally, you take all that information, right? So there's all kinds of information of how it sequenced, how it worked, performance measurements from the air balance contractor, and you're able to compare that to results from previous years to verify proper performance. Now, if there's not proper performance, just like any other inspection, testing, and maintenance, procedure, there's deficiencies and corrections that are kind of written up and provided to the owner that they then are responsible for, kind of getting corrections and those items corrected. Now, that could be various things. It could be electrical. It could be, sprinkler. It could be fire alarm. It could be HVAC. It could be any number of things that kind of had a problem. Most of them are HVAC related, especially when you're kind of going through it for the first time. There's a lot of issues there. So the documents that should be included in that report, the system overview, it's very important to understand the applicable code and the requirements at the time of the system installation. We're not trying to make this thing for an existing system meet new code requirements. So you have to have an understanding of that originally, and that's what's so vital about that. System performance requirements was required at the time of installation. You kind of want to cite that, so that becomes part of the annual, semi-annual test report, that, kind of your lead testing agency or sort of smoke control special inspector for the existing system can help put that together. Your overall test results, the air balance reports showing the performance of the mechanical systems, the deficiencies that are brought up and a copy is provided to the owner and property manager, right? So, and that owner property manager then retains a copy and provides a copy to the local building or fire department upon their request. So, if you're a local building or fire official that, maybe there's an addition or a renovation or something happening in the building, and they might say, hey, give me all your, semi-annual and annual testing for all your fire and life safety systems, including smoke control, as an example. So, for smoke control systems for fire alarm vendors and installers, I wanted to kind of give you some major takeaways that you could take away with this. Fire alarm systems often control the smoke control systems, but that does not mean you own the smoke control system, right? It's no different than interfacing with the elevators, right? You're kind of doing maybe a recall or an alternate floor or a hat or, kind of whatever, interfacing with that. But they're separate systems, but the fire alarm system is integrated to the smoke control system to make up the smoke control system. NFPA 72 testing doesn't make you compliant with all the inspection, testing, and maintenance required for the smoke control system. It makes you compliant with the fire alarm portion of your, 72 requirements. If you're upgrading or replacing the fire alarm system with the smoke control system in the building, get the smoke control system annual report. It's going to save you a lot of headaches to try to make sure that they've done it. What you'll find is they most likely haven't done it. So if there is no smoke control report for that building, insist on it, or you'll be tangled in and, kind of what is in scope and what's out of scope, and you're just going to get sucked in. So, there's interfaces to that, but especially for these older smoke control systems that have not been maintained, it takes a lot of time and effort, including getting service companies involved, including fire alarm service companies, to detangle all that stuff. So you're testing things and fans aren't turning on or actuators aren't actuating because this stuff has been sitting there sometimes for decades not being used. So some of you, I'm sure, have kind of felt and dealt with kind of some of these things and getting sucked into these existing smoke control systems. So make sure that you're clear in doing that. And these non-smoke control systems is definitely going to eat up a whole bunch of your time to try to get this thing back on track. So the owners and property managers are responsible for maintaining the smoke control systems. It's not your requirement, unless someone's paying you explicitly to test those smoke control systems as part of it. The smoke control system test is not part of a NFPA 72, kind of minimum required test. So you want to get a knowledgeable, experienced smoke control, fire protection engineer involved, or refer them to the owner. Maybe the owner's not doing this stuff, and maybe if you pass along or refer, someone like a Jensen Hughes to an owner to kind of get them to test out their system and get that properly set up and maintained to kind of make that fire alarm system upgrade or replacement go a little smoother if you're dealing with smoke control. The semi-annual and annually smoke control test has a role for the fire alarm, and it's not, like I said, not part of the fire alarm ITM. It's part of the smoke control inspection, testing, and maintenance. So, kind of some people try to throw it all in or say everything's owned, but minimum 72 requirements for ITM does not include these smoke control end-to-end tests. It's an important piece, and we certainly need the fire alarm service companies kind of involved to make it all happen, because they're an integral piece of that. And then you do have to watch out when you start upgrading and replacing fire alarm systems that do control smoke control systems. In some jurisdictions, that triggers a smoke control panel, i.e. Boston. So, Boston, if you're in there putting in a new smoke control panel, either as a new system or a panel upgrade, they're looking for a smoke control panel, and kind of having someone to understand what that all means and what, you're not trying to do everything like new, but there are some things that can get negotiated with Boston as part of that. And then to the right here are some disconnect switches and some motor control starters for some various stair press fans and exhaust fans as part of a smoke control system that's an existing older smoke control system. So you kind of see, especially in the existing stuff, all kinds of different shapes and sizes and configurations, and kind of there's an evolution of smoke control over a period of time. So when you've seen a whole lot of that stuff kind of over time, you kind of understand a little bit better, based on the age of the building or the time these things went in, what they were trying to do, and kind of whether stuff was done. We've seen fine stuff all the time that kind of probably was never in right from day one. So when the building originally opened, and then we can open it up for some questions.
All right. Well, Carson, Dave, really appreciate your input, and that was a great presentation. It looks like Dan Finnegan has a question. Go ahead.
Yes, thank you, gentlemen. Dave, this was a terrific presentation. Well done. I learned a lot, refreshed my memory of a lot. The one point I was wondering if it's been enforced yet is NFPA-4 active in the Boston or greater New England area? Because you touched on this importance of integration a lot, and it absolutely is. But NFPA-4 doesn't kind of adds a new flavor to this. I was just wondering if 4 was being enforced as of yet.
So officially not as of yet. However, kind of Cambridge has had kind of a lot of experience with it, especially because of Harvard, as you well know. Kind of Harvard does a whole lot of that, kind of integrated testing and commissioning type work, and so they've liked it a lot in Cambridge, and so unofficially they've been, kind of, I've seen it on more and more jobs, them trying to kind of do some NFPA-4 integrated testing, which is, smoke control would be a piece of that, but that would even apply to non-smoke control buildings, also, because you could have an, kind of an integration of fire alarm, sprinkler, like all these different systems kind of plugged in. However, I will say it's for Massachusetts. So I also sit in Massachusetts, I'm the vice chair in the technical committee for the BBRS, who promulgates the building code. So the next edition of the Massachusetts State Building Code is going to be based on the 2021 IBC.
Yep.
And the 2021 IBC has specific language adopting NFPA-4 for any high-rise buildings and for smoke control. That's really kind of unamended IBC language. Actually, the 2018 IBC also has that language. It's just in Massachusetts, we're still on the 2015 IBC. So that will be coming to Massachusetts. So, and those, kind of that kind of testing is even further integration, kind of those systems. But what you end up doing is really doing a whole lot of end-to-end testing, making sure the building starts now working holistically, so that kind of you're checking not only is your fire alarm and smoke control working, but are you dropping the doors that you're supposed to drop? Are the doors working properly? There's a lot of different things that get plugged into that. But so, there's not a wholesale NFPA-4, adoption as of yet in Boston, but, kind of it will be coming in whatever.
Dave, thank you very much. Well, good answer. Thank you.
Yeah.
Okay. Any other questions? All right. Well, Carson, Dave, great job presenting. It looks like you covered everything. So that was very informative. So. That was very informative for me as well. I particularly appreciate the tips around the ownership of smoke control as opposed to fire alarm testing and so forth. So I'll keep those in mind. Yeah.
Absolutely. Absolutely. Yeah. Just thought it would be helpful. So we wanted to share it, and thanks for having us today, kind of talk a little bit about smoke control. It's a big education, subject, and there's a lot of parts and pieces and players that are involved, and right. the fire alarm folks are a big piece of that. So kind of we think it's important for people to understand.
Okay, great. And for those of you who may have joined late, or for your colleagues, the session will be posted on the AFAA New England website, AFAA-NE.org. So thanks everyone for joining. Thanks again to our presenters, and have a great day, everyone.